Hi everyone, in this video we are going to discuss about a very interesting application of the reflection of a point on a straight line. Let's suppose you have a situation like this. We have been given the equation of a straight line whose equation is ax plus by plus c equals 0. Also we have been provided with the coordinates of two different points on the same side of the straight line. Point A whose coordinates have been given as x sub 1, y sub 1. Point B whose coordinates have been given as x sub 2, y sub 2. Now we have to find the location of a point P such that AP plus BP is going to be minimum, and also AP minus BP is going to be maximum. So two different situations. First we are going to investigate the first situation where AP plus BP is going to be minimum. In that situation we have to find out the location of the point P on the straight line. So essentially we have to find the coordinates of point P that will make AP plus BP as minimum. Now the location that I have chosen so far, the location of P, I really don't know whether that is the correct location of P to make AP plus BP as minimum possible value. Now we could have a situation like this. Here again I have chosen another point P sub 1. I really don't know whether A P sub 1 plus B P sub 1, that value is going to be minimum. I really don't know, but I am just considering all the possibilities here, right? Now let's look at another possibility. I have chosen another location P sub 2. Here again A P sub 2 plus B P sub 2, whether this is going to be a minimum possible value, we really don't know. So somehow we have to find out what would be that most suitable location of P so that AP plus BP will be a minimum value. Now if we join A and B, it's going to look like a triangle. And if we look at these triangles, we really don't know which particular location of P is going to present us AP plus BP as the minimum value. Now if you look at the triangle carefully, you will realize that if we can somehow make the angle APB as 180 degree, then AP and BP, they will eventually coincide with AB, and that will give us the minimum sum of AP plus BP. So somehow we have to try and make the angle APB as 180 degree. But in this diagram, there is absolutely no way that we can make angle APB as 180 degree. No matter where you position P, you will never be able to create a triangle where angle APB will be 180 degree. No matter where you choose P, you will never be able to come up with that angle APB as 180 degree. We can make it 0 degree. We'll see it in our next discussion here. But in the first discussion, we are now trying to see where we can position P so that angle APB will become 180 degree. Well, in this diagram, we won't be able to create angle APB as 180 degree. So what do we have to do then? Well, we have to take the help of a little bit of transformation here. So let's take the reflection of point B on this straight line. So what would be the image of point B? Let's suppose the image of the point B is B prime, and then I'm going to join B prime with P, P sub 1 and P sub 2. And since I am taking an image of B, in each of these cases, whether it is the location P or P sub 2 or P sub 1, in each case you will realize that PB is equal to PB prime, or P sub 2B is equal to P sub 2B prime, or P sub 1B is equal to P sub 1B prime. Now why I say that? Well, because it's an image BB prime is perpendicular to the given straight line, and also the line joining B and B prime, that means the line segment BB prime is bisected by the given straight line. So this is actually forming a pair of congruent triangles. The two smaller triangles that we see there, the bigger triangle B prime P sub 1, or let's say B prime P, that triangle is actually bisected into two congruent triangles. So essentially PB is equal to PB prime, and similarly P sub 2B is equal to P sub 2B prime, or P sub 1B is equal to P sub 1B prime. Now if you look at these three situations, in the first situation when we are using P as the location of the point, then in this triangle you see the angle APB is pretty close to 180 degree, but not quite 180 degree. Now let's look at the other location, which is P sub 1, and if you look at that triangle A P sub 1 B prime, in that triangle again the angle A P sub 1 B prime is also getting closer to 180 degree, but not quite 180 degree. And now if you look at this one straight line, which is A P sub 2 B prime, that one straight line, right? On that straight line, if you think about it, the angle became 180 degree, and that is why the two line segments AP and PB prime, they kind of coincide on top of the AB prime line. So in this particular scenario, we can clearly see that the sum of AP plus BP is going to be minimum. In all other cases, no matter where else you position P, that sum will be greater than this length AB prime. So AB prime is the length which is going to be the minimum value of AP plus BP. Which means that if we take the reflection of B and then if we join the image of B with the original point A, it is going to form a straight line, and that straight line will intersect the given straight line, and that point of intersection will be the most suitable position of P, so that AP plus BP will be minimum. And I have noted this right here. I say that for AP plus BP to be minimum, P has to be the intersection of the original line and the line joining A and the image of B. So this is our geometric investigation. Now we are going to look at the properties of triangle to see if we can prove it some other way. If you look at the triangle APB prime, what would be the value of cosine of angle APB prime? Well, that can be written as AP squared plus B prime P squared minus AB prime squared over 2 times AP plus B prime P. Also, we know that the value of cosine of any angle is between -1 and +1. So we can write it as cosine of theta greater than or equal to -1 and less than or equal to +1. -1 happens when theta is equal to 180 degree and +1 happens when theta is equal to 0 degree. So here we know that we are trying to make the angle as 180 degrees. So I am going to use that inequality where cosine of theta is greater than or equal to -1, and I am going to proceed with this inequality and see what we can find out. So if we multiply both sides by 2AP times B prime P, then our inequality going to look like this. And from here, if we reorganize the terms a little bit, our inequality can be written like this. And from there we can say that AP plus B prime P whole squared is greater than or equal to AB prime whole squared. And from there we can say that AP plus B prime P is greater than or equal to AB prime. So what would be the minimum value of AP plus B prime P? Well, that will be equal to AB prime, because AP plus B prime P is greater than or equal to AB prime. So from here we can say that the minimum value of AP plus B prime P will be equal to AB prime. And that is possible only when P is located on the line segment AB prime. So let me quickly jot down the steps here to solve a problem like this. And the steps are going to be something like this. First, we have to find the coordinates of B prime. I have already created a separate video on this topic where we have seen how to find the coordinates of the image of a point when reflected on a given straight line. So using that theory, we can easily find the coordinates of the image of the point B, and then we can also find the equation of the straight line AB prime, because A's coordinates have been provided already and we have calculated the coordinates of B prime. So we can easily create the equation of the line AB prime. And then all we have to do is we have to solve these two equations. I mean the equation of AB prime and the equation of the original given straight line. If we solve them, we are going to find the location of P. I hope everything made sense so far. Next, we are going to see how to find the maximum value of AP minus BP. I mean what would be the suitable location of P so that AP minus BP will be maximum. Now, to be able to find the maximum value of AP minus BP, I am just going to use the trigonometric method here, because geometrically it will be very difficult to explain, but trigonometrically let's see how that looks, and then we'll try to look at the geometry a little bit. I have taken 3 possible locations of P here, and we really don't know which location of P will result in the value of AP minus BP being maximum. But let's try to find that out trigonometrically. If we take the triangle APB, there we can say cosine of angle APB is AP squared plus BP squared minus AB squared over 2 times AP times BP. That's from the cosine law. And here we are going to use the other inequality where cosine of an angle is less than or equal to +1. So using that inequality, we can say AP squared plus BP squared minus AB squared is less than or equal to 2 times AP times BP. All I have done is I have multiplied both sides of that inequality by 2 times AP times BP. And if we rearrange the terms a little bit, we can write the inequality like this. And then on the left hand side, you can see that we are going to have AP minus BP whole squared, and on the right hand side, we are going to have AB squared. And from there, we can easily say that AP minus BP is less than or equal to AB. That means the maximum value of AP minus BP will be AB, because AP minus BP is either equal to AB or less than AB. So the maximum possible value would be equal to AB. So now if you look at the geometrical drawing here, if you look at the white dotted line, there you will see that when A, B and P, they are on the same straight line, then only we can have a situation like this where AP minus BP is equal to AB. Why I say that? Because here we have used the value of the angle as 0 degree, which is why I am using that inequality, which is less than or equal to positive 1. That is possible only when the angle APB is equal to 0 degree. So when angle APB becomes 0 degree, that is when we are going to have the maximum possible value of AP minus BP. Now when angle APB becomes 0 degree, how is it going to look like then? Well, P will be on the same straight line as AB. So if we join AB and extend that, it is going to intersect the original given straight line, and that point of intersection will be the most suitable location of P, where AP minus BP will attain the maximum value. So here I have noted that P must be on the line AB and angle APB has to be 0 degree. That is when AP minus BP will become the maximum value. So to solve a problem like this, we have to find the equation of AB. We can easily do that because we will be provided with the coordinates of A and B. So from there we can formulate the equation of AB, and then we will be provided with the equation of the original straight line. From there we just have to solve those two equations to find the coordinates of the point P. I hope everything made sense. Thank you for watching. See you in the next video.